This lesson is to compare functions in different representations, estimate. You have studied different types of functions and how they can be represented as equations, graphs, and tables. Below is a review of 3 types of functions and some of their key properties. For linear functions, the equation was y equals mx plus b. An example of that would be y equals 2x plus 1. 2 is the slope, 1 is the y-intercept. M is slope, b is y-intercept. The graph is a straight line. They always have constant first differences. Quadratic equation, y equals ax squared plus bx plus c. A could not equal 0. Remember, that means there has to be a squared term in order for it to be quadratic. An example would be y equals x squared minus 2x plus 3. Remember, the c value, the plus 3, would always be the y-intercept. And it's in the shape of a parabola, which either opens upward or downward. It will always have constant second differences. Exponential functions are y equals a times b raised to the x power. A cannot equal 0, there needs to be an a value, and b cannot equal 1, and b is going to be greater than 0 or positive. So an example would be y equals 0.5 times in parentheses 2 raised to the x power. It's always a smooth curve, either coming from the left or the right, and the graph can go up or down, and they will always have constant ratios. Sonia and Jackie each bake and sell cookies after school. They each charge a delivery fee. The revenue for sales of various numbers of cookies is shown. Compare the girls' prices by finding and interpreting the slopes and y-intercepts. You can see Sonia's revenue, the cookies sold, the number of cookies sold, and how much money she earned. And then you can see Jackie's revenue in graph form, with the cookies sold as the x-axis and the revenue earned as the y-axis. The slope of Sonia's revenue is 0.25, or 1/4, and the slope of Jackie's revenue is 0.30. This means that Jackie charges more per cookie, 30 cents, than Sonia does, 25 cents. Jackie's delivery fee, $2, is less than Sonia's delivery fee, which is $5. David and Arturo each deposit money into their checking accounts weekly. Their account information for the past several weeks is shown. Compare the accounts by finding and interpreting slopes and y-intercepts. You can see Dave's account in weeks 0, 1, 2, 3, and his balance 30, 42, 54, 66. And you can see Arturo's account starts with the line up for the y-intercept and then increases by the number of weeks 1, 2, 3, 4. This one's for you to try on your own, and then you can check back for your answer. The slope of Dave's account balance is $12 per week, and the slope of Arturo's account balance is $8 a week. So Dave is saving at a higher rate than Arturo. Looking at the y-intercepts, Dave started with more money, $30, than Arturo, who started with $24. Remember that nonlinear functions do not have a constant rate of change. One way to compare 2 nonlinear functions is to calculate their average rates of change over a certain interval. For a function f of x whose graph contains the points x1, y1, and x2, y2, the average rate of change over the interval x1, x2 is the slope of the line through x1, y1, and x2, y2. An investment analyst offers 2 different investment options for her customers. Compare the investments by finding and interpreting the average rates of change from year 0 to year 10. So investment A, you can see, is an exponential form and it curves upward. And investment B, you can see, is the chart of information. So you're going to calculate the average rates of change over 0, 10, by using points whose x coordinates are 0 and 10. So investment A, we're going to use, and remember it's y2 minus y1 divided by x2 minus x1. It's the slope formula. So we're going to use 66 minus 10 divided by 10 minus 0, and that equals 56 tenths, or 5.60. And for investment B, still the same slope formula, y2 minus y1 divided by x2 minus x1. We have 66.50 minus 9 divided by 10 minus 0, which is 57.50 divided by 10, which is 5.75. So investment A increased about $5.60 per year, and investment B increased about $5.75 per year. Compare the same investment average rate change from 10 years to 25 years. This one's for you to try on your own, and then you can check back for your answer. So you need to find the slope, the average slope. So we are going to use y2 minus y1 divided by x2 minus x1. So we have 42.92 minus 17.91 divided by 25 minus 10. So we get 25.01 divided by 15, which is approximately 1.67. And then investment B, 33 minus 16 divided by 25 minus 10 equals 17 divided by 15, which is 1.13. So investment A increased about $1.67 per year, and investment B increased about $1.13 per year. The minimum or maximum of a quadratic function is the y value of the vertex. Compare the functions y1 equals 0.35x squared minus 3x plus 1, and y sub 2 equals 0.3x squared minus 2x plus 2 by finding minimums, x-intercepts, and average rates of change over the x interval 0, 10 for 10 years. So for this one, the minimum, the y1 equals 0.35x squared minus 3x plus 1. The minimum was negative 5.43. Remember, it's the y value of the vertex, so you have to find the vertex. The x-intercepts, when you find out what they are using quadratic formula, 0.35 and 8.22, and the average rate of change over the x interval, 0, 10, would be 0.5. And then for the y2 equals 0.3x squared minus 2x plus 2, the minimum, once you find the vertex, you have to find the axis of symmetry and plug it back in, find the vertex. The y value is negative 1.33, and then you use quadratic formula to find the two zeros, the x-intercepts, and you get 1.23 and 5.44. And then the average rate of change over the x interval, 0, 10, is 1. Students in an engineering class were given an assignment to design a parabola-shaped bridge. Suppose Rosetta uses y equals negative 0.01x squared plus 1.1x, and Marco uses the plan below. Compare the two models over the interval 0, 20. This one's for you to try on your own, and then you can check back for your answer. So Rosetta's model has a maximum height of 30.25 feet and a length of 110 feet. The average steepness over 0.20 is 0.9. Rosetta's model is taller, longer, and steeper over 0.20 than Marco's.